going to be pretty rough sitting here in this chair, being chained to it and not being able to pace around like I usually do. This is going to be tough. All right, everybody. My name's Rick. I think pretty much everybody knows who I am. If you don't, there's more information on the slides. And we're going to get started by talking about interfacing Visual FoxPro with .NET. And whoops, that was great. That's a great way to start. Yep. So we're going to be talking about interfacing Visual FoxPro with .NET. And I've given this talk quite a few times. And every time I do it, it's a few new things thrown in. There's a bunch of new things in www.NetBridge to talk about, and also some things that have changed in .NET. Towards the end of this session, we'll talk about creating .NET components, and that's gotten a lot easier since the last time I've given this talk, so we'll talk about that as well. All right, you ready?
Yes.
Come on, people.
Let's do it.
All right. All right, so this is what we're going to talk about. How many of you have used .NET before, or www.NetBridge and interfaced? Okay, so almost everybody. Wow. Oh, that's cool. I guess we're going to spend less time talking about the very intro stuff and jump right in. So basically, we're going to briefly cover why you would want to use .NET with Visual FoxPro in the first place. Obviously, that's important to decide whether you want to use this technology at all or whether you want to use something else. And then at the same time, also, why would you want to use www.NetBridge, which is yet another layer on top? Yes.
Sorry, Rick, I just want to stop. I think we've got
getting
the wrong screen out going out to the world. They're just seeing you talk. So, Charles,
it's this right hand.
Yeah, try that. Try that.
Go back to this one.
Technical issues.
Yeah.
Hold on.
For some reason, you're not sharing.
You're not sharing your screen.
Oh,
Me?
Yeah, put that one back in. No, that's me. You don't want me. Yeah, we had two. There were two things we were getting from you before. We were getting your screen share and your camera. We're only getting your camera.
Is there anything you need from me, or is that just on it?
You need to share your screen through the hub-in, or through the backstage thing.
Well, we did that already.
Your PowerPoint.
Present. Share screen.
Rick's taking care of it for you.
Share screen. Entire screen. This screen. Share. It was working. We had it set up, right?
You have to add it to stage, Charles.
I got to remove.
The other one.
There.
One just came up. Add that to stage. There you go. Now go.
Now it's cinema mode.
Okay. Now you just need to get your PowerPoint.
There we go. Ah.
20 seconds for it to catch up.
Oh man. No, we're good.
You're gonna swear, smart now.
Wait, there's only a 5-second delay, right? All right. So anyway, why would you want to use .NET? And we'll talk about that in just a second. And then also, why would you want to use www.NetBridge, which is technology that's running on top of .NET, the .NET framework itself, to interface with it. And then the majority of the session, we're going to show examples, a whole bunch of examples. So hopefully that's what is exciting, and that's what's fun to work on and show you, and hopefully also gets you excited about doing some of the stuff that I'll talk about. And then towards the end of the session, we'll talk briefly about how to create components. And I say briefly because it's gotten so much easier that there isn't really all that much to talk about, actually. So that's actually a good thing. All right, ready? And I don't know why my keyboard isn't working, so that's going to be another interesting one. Okay, so why .NET? .NET has basically become the interop technology for Windows in general. Okay, so if you think about Microsoft producing new features in Windows or producing new APIs like the Copilot APIs or the various AI APIs, for example, all those things nowadays get published as .NET pieces. So we as FoxPro developers, we come from a different era, right? I mean, back then, the extension technology was COM. And who's heard of anybody publishing a new COM library? That just doesn't happen anymore, or very rarely if it does. And so everything these days is basically getting published as COM object, as .NET objects. Luckily, .NET actually has the capability of being accessed through COM. So we can actually interact with it from FoxPro. So the vast majority of functionality that is available in .NET is actually available to you in FoxPro. Now, it's not quite as straightforward as straight COM objects, but you can actually do it. So why we want to do that is because, as I said, Windows itself exposes new features, and we can take advantage of those features. But in addition, there's also a huge ecosystem that is associated with .NET, and essentially we can take advantage of that. So there's literally thousands upon thousands of components that are available that do all sorts of stuff that you can integrate with from within your Visual FoxPro applications. And you can easily get those pieces via the NuGet package manager that is now built, well, that has been built into .NET for a long time, that allows you to pull all the dependencies all in one easy get-go. So you can basically run one command and pull down all the DLLs and dependencies that you need that you can then add to your project and work with when you need to actually access these components. So it's a great way to extend FoxPro with new functionality because there's so much functionality available. And additionally, you can build your own components. So you can actually build .NET components and then call those from FoxPro. And it's a great way to slowly get started in a new technology because you essentially can build small little components that just do a little bit, and then maybe you do a little bit more on the next one, and then a little bit more on the next one. And eventually you have a whole bunch of stuff that can cooperate with FoxPro. And you've started your first steps into moving into a different direction, perhaps. Now, I know a lot of people don't like Microsoft because of what they did to FoxPro and whatnot. But let's be clear. This is really the only technology that is really accessible for integrating with directly from FoxPro. Most of the other technologies are kind of something that you have to do completely separate, right? But because .NET is COM-enabled and easily lets you create COM components that you can then integrate with directly, allow you to actually very easily integrate with that technology. So I think that's very, very important. So then what is www.NetBridge and why do we even need it? OK, so .NET has built-in COM interop. I mentioned that, right? So there's actually a mechanism built into it that you can instantiate .NET components from .NET. From another platform like Visual FoxPro. So you can do create object on certain types of objects that are actually registered in .NET. Unfortunately, there's a huge limitation. And the problem is that these components have to be registered. And they have to be explicitly marked as being able to be executed via COM. So there's a COM visible attribute that has to live on that. And the big problem is almost no components in .NET implement that. When they first created the .NET framework, there were a whole bunch of classes and components that were COM-enabled. And the intention was to publish it that way and allow you to do that. But that never was extended out forward. And no third party ever has a COM visible attribute. So you can't actually directly instantiate and create object of .NET objects in FoxPro at the moment, at the time. So it's just not possible to do that if they're not explicitly enabled for that. And so what that means is that you basically are limited to those few components in the framework that have the ability to be directly instantiated. Or you can build your own components and then interface with those, and those can talk to other things. Okay, so this is native COM interop that's built into .NET. So that's one of the big limitations. The other limitations of native COM interop is the fact that there are many types in .NET that don't translate to COM and FoxPro. So if you have a value type, or you have a generic type, or you even have a simple thing as a long or a decimal, those don't translate into FoxPro. They can't travel over COM. And so there needs to be some help to provide you that capability in order to translate and make those types work for FoxPro. And that's what www.NetBridge basically provides. So www.NetBridge is a third-party library that I created. It's open source. It's on GitHub. It's free. And there's also a commercial version that ships with all the Westwind products, the FoxPro products. And the commercial version and the open source version are basically the same, except for a couple of additional things that were added to that add dependencies. So there's, for example, a bunch of JSON parsing and XML parsing functionality, and then also some custom library stuff that is built on top of www.NetBridge that's not in the base version. But otherwise, the core functionality and everything that I'm going to show in this session works with the base version of the base open source version. So it's completely free, and you can get it on GitHub. So what does it do? Basically, www.NetBridge can be thought of as a proxy between FoxPro and .NET. And so what it does, it sits in between FoxPro and .NET and allows you to execute and do certain things inside of the .NET framework from FoxPro. So rather than instantiating that object directly via COM interop, we can actually tell www.NetBridge, create an instance of this object and hand it back to me. Behind the scenes, www.NetBridge still uses the same COM interop that we were using, that native COM interop uses. So there is COM involved in all of this, but www.NetBridge basically shortcuts the mechanism of creating the .NET runtime and then initially loading the individual types and loading assemblies and things like that. So the basic invocation process has changed with www.NetBridge, but everything that you do afterwards still moves over the same COM interop mechanism that .NET natively provides. So everything we're doing happens over COM, basically. So the most important thing that we do is we load assemblies, we create instances, and then for those types that don't work, there's indirect methods that can be executed from within .NET. So this is where the proxying comes in. I can say if there's a type that has a certain, that is maybe a generic type, and I need to call a method on it, over COM, that would just not work. With a direct COM call, if you want to call a method, it's just not going to work because COM cannot support generic types. So instead, you can get an instance of that object, create it, and then actually indirectly invoke methods on it. So there's on the www.NetBridge object, there's an invoke method method that you can call to invoke a method indirectly from within .NET, and then basically bring the results back to you via the indirect proxying methods. So that's going to be a little bit slower, but it provides the functionality to access almost all of the functionality that's available in .NET. I would say there's about 99% of the functionality in .NET is accessible now directly from FoxPro using www.NetBridge, which is pretty cool. Okay? Any questions on that so far? Okay. So then the architecture looks something like this. So in this picture, we basically have some FoxPro code on the bottom, a .NET object that we want to instantiate. And so what happens is the first thing is we load www.NetBridge. And when we do so, it creates basically an instance of the .NET runtime and then loads a .NET object inside of it. And so that .NET object is our www.NET proxy object. And it's a .NET object that sits inside of the framework that we can communicate with from FoxPro that acts as that indirect proxying mechanism that we can use to call, create instances, call methods, access properties, and whatnot. And it will do translations for certain types that are problematic. Okay, so when we first do this, there's a small native DLL that gets loaded, and that DLL is basically responsible for hosting the .NET runtime for us. And then it creates that www.NetBridge.NET object, which is passed back to FoxPro, and the FoxPro class that sits in front of that uses that object to actually do all of its tasks. So when you say hello-bridge.invoke method, it's going through that FoxPro object to the .NET object, then invoking the task, and then basically coming back to do this. So what that looks like is we have the pass-through, and then once we have a reference to that object that gets returned to us, if we create an instance, we can use regular COM interop. So if it's an object that just supports basic properties and methods, we can call everything directly, just like you would be able to do with regular COM interop. And then if it's something that's problematic over COM, then you use invoke method or get property or set property. Okay? All right. So that's it for the architecture part of this. On to the examples we go. You ready? Any questions? All right. So let's start with the 101. So when we create a www.NetBridge, when we access something inside of .NET, the first thing we need to do is basically create an instance of www.NetBridge. And if you look at that code there, the very first thing we need to do is load the library and then create an instance of www.NetBridge. So there's this method called getWwDotnetBridge, which basically does what I showed on that first slide, right? It goes off, creates the .NET runtime, and hands you back that proxy. And so that gets cached. So if you use this particular version of this factory method, essentially, to retrieve that value, the LOBridge object, it creates a new instance and then caches that. So you always get that same instance back. So it'll be very, very fast to get new instances or always have access to it. You can do create object www.NetBridge, and that's not terribly slow, but it's going to be a little bit slower because it has to go back through that DLL, check to see if the runtime is loaded, and then otherwise comes back. Okay? So then the next thing we need to do is we need to load an assembly, most likely. So if you're going to talk to a third-party component, that's going to be a DLL that lives on disk somewhere. So you can point to that DLL, or it can be in your FoxPro path. So in the examples that I'm going to show here, we're going to have an application directory where all the samples sit, and then a bin folder. And I've added the bin folder to the path. And so when I instantiate, all my .NET DLLs go in that bin folder. And www.NetBridge finds it in there because it's in the path. So it looks for the DLL, full path is out, and then uses that DLL from there. And the next thing we do then is create an instance. And when we create instances in .NET, the important thing is that we need to specify the class name. And the class name in .NET is going to be a namespace and a class name. And I'll show that in just a second. So just hold the thought on that. So the instance that gets created then gets returned to you as a COM object. So it works as any other COM object. So if it's a simple object that just has properties and method, and there's nothing complicated about that object, you can directly access those methods and call them just like any other COM object, just like any FoxPro object, actually. And it's very, very fast. I mean, you do get a little bit of overhead for COM, but it's very, very quick. Okay? So then any calls that you make directly, like if you invoke a method, you just call the method and pass the parameters that you need to call. So when does that not work? If you have methods that have overloads. So in .NET, you can have methods, the same method that has multiple signatures with different parameters signatures. So if you have multiples of those, then that doesn't work direct. You can't call it directly. COM will subscript those. So there's an _1, _2, but it's hard to figure out exactly what's what there. So it's better to just use LOBridge.invoke method. Then you pass an instance of the object that you want to talk to, and then the method that you want to call, and then all the parameters that you want to pass. Okay? And same thing with properties. You can directly access a property and assign a value to it, or you can use LOBridge set property, LOPerson, and the value that you're trying to access, or get property, retrieve the value back. Okay? So let's take a look and see what that looks like when we actually run this. So all the samples that I show here are part of the GitHub repository. I highly recommend you clone that repository and you can play with it. All the examples that I have here are ready to run, so you should just be able to download it and go off and just shoot right off. Okay? So do .NET 101. I think that's the first sample here. All right. So first thing we do is we load the library. So this basically sets procedure to www.NetBridge. Then we get the instance of www.NetBridge. So since this is the very first time, it now goes out, creates a .NET runtime instance, and hands back that proxy object inside of .NET to the LOBridge object. And as you can see, it's pretty fast. I mean, it takes a fraction. It hesitates a little bit, but if I do it the next time, because it's going to be cached, it's going to be much, much faster. Okay, so the first load takes a little bit of time, but it's still under a second, right? But you want to avoid having to go through that DLL path, even if it's not very long. Next thing, we load the assembly. So I'm loading a sample assembly here, and we'll look at that in just a second. And then I'm going to create an instance of a class, and it's the namespace and the name of the class that I'm going to instantiate. I'm going to show that just in a second here. Let me actually go over here. Okay, so here's that person class. Let me see if I can resize this to fit perfectly here. So here's that person class in .NET. So here it's inside of this demo project that I created. So it's a demo project called www.NetBridge demos. Okay, so by default, the namespace is called the same as the base namespace is called the same as the project name. So it's www.NetBridge demos and then the name of the class. So this is what I need to use as my class name when I do a create instance call. Okay, and then this class has a name, a company, a display name, an entered, and a list of addresses, which happens to be a generic list, and that'll be important in a minute, and another sub-object, which is the primary address, which is computed. Basically, it finds the first address and returns you the address. And then down here, I have an address object, which is what these addresses are made up of, right? So I have multiple addresses, and the primary address is a type of address. And so the address lives down here, and it has street, zip, and whatever. And so we can access this. So when we look at this, this is a typical object. So we have a person object, and we have a person.name, person.company. We have a person.primary address, .street, .city, and so forth, right? That makes sense? Okay, if we go back to FoxPro now, and we keep on stepping here in the debugger, if I can find it. Okay, so we're in here, and I'm going to create an instance of this object. So there's my person object. This is a COM object now. So if I go into the debugger, you will not see all of its properties. Why not? Because it's a COM object, right? Until you use one of those properties, they're not visible. The debugger can't actually show you those. Okay, so how do I find out what's there? Well, in the commercial version of www.NetBridge, you can actually do to.json, and it will dump out the JSON for this. Okay, so that's one way. It's pretty nice, right? I mean, it's a quick and easy way to see what's available on that. So we can see here the same structure of what I just showed you. Or if I get my cursor back here, I can go back in here and go explore. Oh, yep. And I'm going to go into my bin folder, and I'm going to go down to my www.NetBridge demos here, and I'm going to run another program here called ilspy, which is a .NET disassembler. And a disassembler is basically a tool that you can use to find out what is the functionality of this class. What are the types on it that I can play with and work with? Okay, so that I'll zoom this in here in just a second. So what I'm going to do is I'm going to actually take this out of here and show this properly. So what I can do is I can take this www.NetBridge demos DLL that exists here in that folder, drop it on here, and now go in, and I'm going to drill into my person object here. Okay, and I'm also going to open that, and then I'm going to maybe zoom in here. Okay, can you see that okay now? Okay, so a little hard. I can't. There we go. Okay, so here's my person, and it will actually show you here on the side what that looks like. Okay, so then you can look at all the fields that are available, all the properties that are available, and then here is the address object with the city, state, street, and zip. And interestingly enough, if you look, a little hard to get around there. If we expand this out, you can also see that this really is a decompiler, because it's actually decompiling the code, right? I mean, there's the code for the display name, and there's the code for the toString, which displays the display name and the primary address and the toString method of it. Okay, so it's taken actually the code that was there, that's in the IL code, and decompiled it back into its original source code. Okay, that's not the important part. The important part is that you can use this disassembler to look at what's available for you to use. Okay. All right, so if we go back into Visual FoxPro now, into the debugger here, and we keep stepping, okay, so that's going to clear that out. So then we have an instance of this COM object, this person COM object that came down. Okay, so now we can step through name, company, entered. Those are plain properties. Nothing wrong with that, right? So they're just normal properties. So then I can also say hello person.primaryaddress.street. Okay, so now I'm going into that child object. Remember that child object over here, right? We had person, and then there's a primary address object, which returns that first address object of the list of addresses. Okay, so we can basically walk the hierarchy with all these objects that are simple and have no complications of any sort. Okay, you with me so far? Okay, so then if we want to add a new address, so the address object that was the address list that was created originally was created with one address in it. So now I'm going to add another address. There's a method over here called add address, right? So here, there's some code in here basically that creates a new address object with the parameters that were passed in, adds it to the collection, and then returns that address to me. Okay, so that's what this .NET code looks like. And so I'm going to return that. And so at this point, I've added a new address, right? So now I have two addresses in there. And if I step through here, retrieve the addresses, you notice now, notice there the commented code that says, if I directly access this addresses collection, this collection here, if I address this correctly, you notice here that it has a generic type in it. A generic type is basically a type that gets assigned at compile time. So you specify it's a list of some other type. And so at compile time, .NET creates a new class that matches that. If there's another class that gets created as list address, it shares that. But if there's another class of list.person, then it creates another class at runtime when it compiles this thing into its binary code, into its bytecode. Okay, so a generic type is not able to travel over COM. And so what that means basically is that we can't access that in FoxPro. So if I do this here, you notice it says hello address. If I access this, I can get that value back, and it will be an object that I can print out, and it will say, its toString method will basically say that this is an object. But when I try to access any property on it, it will actually fail. In fact, it will crash. It will crash Visual FoxPro. And so I'm not really quite sure why that hard of a crash occurs, but when you do that, it's definitely not a nice thing. So anytime you have a type that's not compatible, it will not work at best and crash at worst. So generic types in particular are the ones that cause crashes, which I don't know why exactly. Does that make sense?
Yeah, good question.
Yes.
Jody's asking, what's the tool that you just talked about a minute ago, the spy tool?
Yeah, so it's called IL. What the question is what was the tool that I used there a second ago to find all the types and all the properties and methods? It's called IL Spy. And all of that stuff, by the way, is in the white paper. Okay, so if you go in the white paper, you can read all about that. So I'm not going into the detail where everything comes from and what everything is. So if any of that interests you, there is a lot of information in that white paper. It's humongous. Surprise, surprise. But yes, you can find out there. And there's multiple tools listed there as well. There are several tools that do that type of thing. Yeah.
Will try catch get you around that type of error, or is it a hard error?
That one actually, in this case, it's a hard error. That literally shuts down FoxPro. In other cases, you can catch that. You can try catch these errors. So you don't typically, you only make that mistake once. Once you know it doesn't work, then you go do invoke method or get property. So that's what we're going to do here, right? So instead, we're not going to call this directly. We're going to say get property, hello person, and retrieve the addresses. And what that does is it now goes out into www.NetBridge, and it creates a wrapper around that type. And it creates what is called a COM array in this case. So the COM array is basically a collection wrapper. So what we're getting back is a list of address objects, right? So it turns that into a COM object that's in .NET. That's a custom class that I created for this that allows me to access the individual items, add a new item, remove an item, clear the list, do all the things that you normally would do to a collection. Add an item if it's a dictionary, so you can add it with a key and a value. and all these things that you can do to it so that we can actually manipulate this item. But all the while, the array or the list continues to stay in .NET. It never actually comes back to FoxPro. So we can work with the elements locally. We can pull out the address and make changes to it, but the collection stays in .NET. And so it never touches FoxPro code, and therefore the code now works, right? So that's what the proxy is for, basically. So if we keep running here now, we should have, let me see here, where's my FoxPro? We now have two addresses, right? So we added that one address via code via that add method. And then we can now print out, we can grab one of the items, so one of the addresses. So what we can say is hello addresses dot item. So that gets you one of the items in the collection that is there. And the list is 0 based. So we start at 0. The first item is 0. The second item is 1, and so forth. Okay. So item 0 gets you the first item in the list. And then we have an address object. And now we can do whatever we want with that address object. We can assign new values to it if we want. And that's visible in .NET at that point. Okay. So that's what we're doing here. And then we're just basically adding back and writing that out. So we're writing out those two new items. Okay, so then the last thing that we can do is we can also add an item to the collection. Okay, so what we can do here is and again, this is that COM object, that COM array object. And I can say hello addresses dot create item. And what that will do is it will look at the collection's underlying type. So in this case, an address object, and create a new address object for me. So it creates it in .NET, returns that back to me. And now I can manipulate that address object and add it. Okay, so I'm basically making an assignment, right? And I add it back to the collection. So now I've created a new item, made changes to it, and then added it to the collection. So now we should have 3 items in the collection, right? The original item, the item we added with the add method, and then one that we added just now. And so when we add back here, it says 3 addresses there on the bottom, on the very bottom. I hope we can see that. And then if we dump that all out, we see all 3 of those items displayed. Okay, so what I've just shown you is kind of a cross-section of the functionality that's available in www.NetBridge. And surprisingly enough, I'm going to say this is 80% of what you're going to be doing with it. This covers the vast majority of what you're going to do with it. There is other things that you will run into, and we'll see some of these other use cases. But this is the vast majority of the things that you're probably going to be doing with www.NetBridge for the typical scenarios. Okay. All right, let's go back to the slides. All right, so now we're into the example. So the first example was kind of a very detailed walkthrough to give you an idea of how everything works. So from now on, we're just going to kind of jam through some of these examples and show the highlights of the things that you can do with this. So the next thing here I'm going to show is a string formatter. So .NET has some really nice string formatting capabilities built into it that allow you to, for example, format numbers and format dates. And we can do a little bit of that with FoxPro and Transform, but it's pretty limited. So in .NET, you can actually use format strings to format a date exactly the way you want it to. And so let me jump to code first to kind of show you what that looks like, and then we can look at the code here. Okay, so let's actually, let me just run it. Okay. So there you can see a few of the things that it's doing. So the top is all dates. So the first one is like HH, uppercase H, for example, is for 24-hour. You make a distinction between 24-hour dates and 12-hour dates, for example. Lowercase h is 12-hour, uppercase H is for 24-hour. MMM is for months as a 3-letter extension. MMM, so four M's, is for the month completely spelled out. And you can make any combination of this. Maybe you want to show a date that only shows the month and the date, but not the year. And you can do that all. You can actually use these format strings and combine them in any way, shape, or form that you want. Okay. So there's also a whole bunch of built-in types. So if you need to display a MIME date, if you need to display a RFC date that is like the JSON date, for example, that's built in. Okay. Same with numbers. If you want to display a decimal point, or if you want to display a zero prefix number, right? So 000, 00 displays two zeros in front of the numbers if it's a single value. Okay, C is currency, so it'll put the current dollar sign in front of it, right? So since we're in the U.S., it will use whatever the current locale is, and then use that dollar sign. So if you're in Germany, it's going to show the euro sign, for example, right? And it will use the proper decimal points, obviously, and commas to separators. Okay. And then the other thing that we can do is we can do string formatting, which is basically the ability to create a template. And so let me go back to the slides here for a second. It's a little easier to see here. Well, actually not. I'm going to have to go to the code. So format string basically gives you the capability to specify a format string and then inject values into it. So basically, you use brackets and a number to specify. So if you've ever done anything in a C-style language, you know what this looks like, right? It's like printf, essentially, except it's more powerful because you get the formatting that I just talked about. You can also add that into that. So basically, in this example here, I have a format string that says, hey, bracket 0. The date and time is 1, and then I actually can specify a format string there, and it will format that for me. And it's pretty powerful because you can do that to any number of parameters. It's kind of like a very compact version of text merge, right? And it's really nice because you can pass in the parameters that you want to replace right there. You don't have to have them pre-existing like you do with text merge. And you don't have the limitation of the text merge function, which kind of screws around with line feeds. So the text merge function in FoxPro is not one to use, really. The text merge command is good, but the function is really quite unreliable. Okay. All right, so lots of ways we can format. And so basically, when you do this kind of replacement here, what happens is by default, if you do not specify a format string of some sort, it will use the toString method of that object or value. So everything that you use in .NET is an object, even an integer or a Boolean value or a string or a date. They're all objects, and they all have a toString method. And the toString method is what the default is that gets dumped out. So earlier in that first example, we had a toString method on our person object, right? And it printed out the entire object. It basically said first name, last name, and the company, and then the address printed out below it. So toString dumps that out. So if I put that in here, for example, in the second example, I have a person object, and I say line feeds, and then I want to embed the person here. So what do you think that's going to print? It's going to print the name and the address out on the output here. So if I run this one more time, right? So the person object is right here on the bottom, and there you can see my name, and there's the address, and then the time is 3:08. So it's basically combined all those things together into one. It's pretty powerful. So it's a very simple function. It's very fast. And I use this all the time. It's very useful for date formatting especially. So just a kind of a practical use case here. Okay, let's go back to the slides. Okay, so the next one is Markdown parsing. How many of you are using Markdown for anything? A few of you. Okay, so Markdown is a text format that represents HTML, basically. So it's plain text. You can type it. It's very, very simple. And so if you look there on the right, you can see what Markdown kind of looks like inside of that text block, right? So you have a few markers that delineate on how to format text. So the pound sign there at the top is a header. So it's a header 1. So that's a heading. The line there that has an image in it is the way you represent an image, for example. And then you can have a list, and you can have a block quote, for example. And so basically what you can do is you can have inside of your application, you can store plain text, but you can actually render HTML from it because it can be converted with a Markdown parser into HTML very easily. So it's very handy for things like a message board, for example. Like if you go to my message board and you type a message in, you can use Markdown, and you can have bold text, italic text inside of it. You can have lists. You can have any of this inside of it, basically. You can also embed images inside of there using an upload that is built into that. So we'll look at that in a minute here, but let's look at the example in a second here. Let's look actually at the example. Oh, so that's not actually what I wanted to show, but OK. So this one too fast. Let me do this one more time. Let me go back to show HTML. So this is a similar piece of HTML, and that's what that looks like if you get the raw HTML from it. So what Markdown to HTML produces is basically a HTML fragment. It's not an HTML document. It's a fragment, right? So you just get basically exactly what you're asking for. You're getting all the tags that this Markdown that you set up is made up of. So the first thing there will be an H1 tag, and then the bottom is, I think, some code or something like that, right? So that's pretty cool. I mean, even that is nice because, I mean, it is really live, right? I mean, we have an image inside of here that's linked from the web because I had a web link in there. And I can click on this link, of course, and that's live. And that will go off to wherever it needs to go to, right? So that all works. Oops, got that one. So what we do want, though, if you are actually going to use this anywhere in an application is we want to take that Markdown or that HTML that we generated and actually make it look nice, right? So if you're doing this in a web application, maybe you don't need to do anything because you already can render it within your style sheet of your web application. But if you're in a desktop application, you probably want to do something like what I just showed earlier inadvertently, which is applying some styling to it. And so when we do this here, you can see that this is the same document, rendered exactly the same, but now I've rendered it into an HTML page that has styling applied to it. OK? So the body of this thing is exactly the same as what I rendered the first time, but I have some HTML headers around this, basically, that renders this in a certain way. And the way that this works is that there is a template engine. Well, not a template engine. It's just a show web page function, or a PRG file here, actually. And essentially, what I pass in the HTML and optionally a file that I want to output to. And what I do is I load a template from a given path. So I'm looking basically at the assets path, westwind theme.html. And if I go back into my code here, and I put in theme.html, we can look at what that looks like. OK, so this is what that looks like. So it's a plain HTML document, but you can see here it has a link to Font Awesome, and it has a link to my style sheet. And then it has some additional script code and styling that is related for the code formatting. OK, so there's actually, if we look at this when it runs, there's actually some code formatting, and we'll look at it again once we get there. So what we do is basically from FoxPro here, I load this template and then do string replacements into it to replace these expressions inside of here. You notice these things here, right? And so this is where I came into a problem with my text merge earlier. So when I was doing this, it was stripping out all the line feeds with text merge. I don't really know exactly why, but I think it is because the line feeds are just a character 10 and not a character 13 and 10. Yes. Yes, I found that out. Yeah. So basically what happens here is instead what I did is I replaced these variables inside of it. So what I do is I load it into a string, do a string tran on all these values, and then that's the HTML that I render at the end of the day. And that's what gets written to a file, and then we're just using shell execute to actually show it. Right? So let's look at this one more time. Let's run this one more time with the markup here. And there you can see the code blocks on the bottom, right? And I mean, there's actually some cool stuff in here, like you can click copy and that copies it. And it's syntax colored, so C# code is colored differently than the FoxPro code. Okay, let's look at how that actually works. Oh. So if we actually look at this, it's actually pretty short. Again, we do get www.NetBridge. We load the MarkDig library. So that's the library that's responsible for doing this here. So MarkDig is a third-party open source library that you can use for markdown rendering. And it has a method inside of it called, OK, so where's the code end here? So inside of it, there is a method called toHTML on a MarkDig down object. Okay, so what we have here is a static method that we are invoking. Okay, so what's a static method? Static method is one that you don't instantiate, is on an object that you don't instantiate. It's kind of like a FoxPro function, right? You're not invoking an object, but you rather calling a method after you set procedure to. So a static method is basically invoked on the type. So rather than having a type that you, a class that you're executing it on, you're specifying the type that you're loading and then invoking the method on it. So there's no instance of a class involved with this. It's just basically a function that's standing on its own. And the only reason that it's attached to a type is that we need to get to it somehow. And so the type in this case is MarkDig.Markdown, and it has a toHTML method. Okay, and that's all it really takes to do this. So that's the simplest thing. Then if you want to extend this a little bit, we can create an object around this. And so what I like to do is basically create a wrapper around most of the .NET components that I create. And basically what I do is in my init method, I load www.NetBridge, assign it so that I have a local instance of whatever objects that I create in .NET. So I'll hold on to the www.NetBridge object because that way it's always available. And I hold on to whatever object I'm actually creating. So in this case, I can create a markdown pipeline that is basically specifies how the markdown is parsed. So I can basically add add-ins onto the markdown parser and say, manage pipe tables, do GitHub flavored markdown, support front matter, support all these different types of things. Okay, so in the init, basically, we load assembly and make sure that works, and then we create an instance of that object. So then there's a create parser object here, a method here, that basically adds all those options that I just talked about. Right? So there's all these options that are being added. And then in the parse method, we make sure that the parser has been created. And again, I love caching things because I don't want to call things over and over again. I keep track of what that is in a variable here on the object. And then I can simply, every time, retrieve that object that was previously created and go ahead and run my markdown conversion. So then I do the MarkDig to markdown conversion, and this time I pass the pipeline to it. And so this takes all those options and basically applies them to the markdown parser. And then additionally, you can do some other stuff. So there's some stuff in here like sanitizing the HTML. But I'm a big proponent of building classes around my .NET components that I call from FoxPro, just so that I can abstract it, I can do the error handling, and it's all isolated. And then you can take that one step further. You can build an application level function that is easy to access. So I don't want to create an object each and every time, but rather I create an instance, cache it, and then have a function that just returns that. So this basically becomes a factory function. So there's a markdown method that I have that has all the options set the way I want them, and I call that in my application. And that's the only thing that I talk to when I need to parse markdown. And it will do all the things that I want it to do. It has the pipeline set up a certain way. It has all the add-ins. It has all the extra options set. And I'm using the right parser for what I need. OK? All right. On to the next one. Two-factor authentication. How many of you know what that is even? You've been tasked, yes? Okay, so two-factor authentication is something that we can actually do with .NET very easily. And so if you want to integrate that into your application, you can do that quite easily. Now, I'm not going to go through of how that works on a website, but basically there's 2 steps involved in that. The first one is you need to be able to generate that QR code in order to be able to add it to your authenticator. So basically the way it works is you have to use an authentication application. So that's Authy or Google Authenticator or Microsoft Authenticator or 1Password, and various password managers support it too. And then you can create basically a generator that generates numbers, pins for you that are valid for a certain amount of time. And so the second part of that is validating that pin. So you generate this, and then you get a key back, and that key gets stored with your application. So basically, you have a secret key that's responsible for generating this QR code in the first place, and then also to validate the pin at some point in the future. Okay, so let's take a look and see what that looks like. So there's a sample here called two-factor auth. Okay, so it generates this, and then it has another sample here to do the validation. And so in order for me to do the validation, I actually have to go into my browser. I'm going to have to go to my store, and I'm going to have to actually pick one of these up. So I'm going to go. So you notice here, I have previously set up a one-time password. Okay, so the way that you would use this code here is to scan it with your phone in your authenticator app. So you can use it, you can scan it here, or if you're using something like 1Password, you can bring it up in a page, and it will scan the page for a QR code inside of it. It will then set up something like this, where it actually has a one-time password setting inside of that authenticator. So I'm using 1Password here just for convenience. But if you were using something else, it could be any of these authenticators would work. But you can only set it up in one at a time, right? It doesn't work across for them. So just one at a time has to be that holds this information. So if you do this in 1Password, which is one of the really nice things about it, is it works everywhere, right? And so that's one of the, and same with the pass keys that are coming out. You can actually use 1Password for that as well. I haven't done that myself, but that's the next thing. Okay, so once I have this, I can copy this, and then I should be able to go over here, paste it in, and now this should validate it. And it says invalid. Hey, did I grab the wrong one? Let me go back over here. I actually need to go to my actual store, I think. Copy that one, go back over here, paste it in. There's pin has been validated. Okay, so now I've validated a valid pin, and I've validated it. So what does that take? What does it take to do this? Okay, so if we look at this here, again, when we run this code, basically I created a wrapper class, and we'll talk about the class in just a minute. But the way that you need to do this is you need to create a secret that gets stored with your application. Okay, so this is basically what you need to hang on to. So typically you'll store this in your database as a two-factor authentication key of some sort. And then you use that key to generate the QR code, so generate setup code. And it gives you that here in this call to generate code, to generate setup code. It gives you back an object, and that object will have the QR code in it as an embedded base64 image that you can then display. Okay, so when I run this here, notice that there is this string that's being displayed up here. That's part of the image that is actually being generated. And does anybody recognize what that is? It's a base64 string, but it's actually image data, right? You can actually embed that into an image's source tag, and it will display an image. In other words, it's very simple to take that and display it inside of the browser. Okay, so that gets generated, and then I can display that on the form, and then once the user accepts that and puts that in their authenticator, you're ready to go. Only thing you need to do is validate it again to make sure that they actually got the right code and whatnot, and that it works. And once you have that, then you store it in your database. And then next time, when the user comes in and validates with that two-factor code, you can actually validate that code with validate pin. which is what we're doing here. So for that, you bring the secret, which is what you have in your database or whatever you stored with your application, and the PIN, and that's all it takes. Okay, so the actual .NET code that sits underneath that is we load the Google Authenticator DLL, we create an instance of the Google Authenticator two-factor authentication object, and then in generate setup code, we basically call the generate setup code method. And then rather than returning the .NET object itself, I create my own object and only return the options that I really want out of that. So there's a few extra things in there that are useless, and you don't really want to have these .NET objects floating around. So in many cases, I actually just create my own wrapper object and then return that instead. Okay, and so then in order to display this, I have this two-factor auth setup auth object, and I have a method on there called QR code HTML. And it does exactly the same thing I was doing with the Markdown. I have a template, and inside of that template, there's an image tag here, and it embeds the QR code directly inside of the image tag. And it's just a text merge, and that actually works just fine. Okay, and that's how that image gets created. This is how we're seeing that HTML page. Now, if you're doing this in a web application, which is the most likely place that you're going to be doing this, you're not going to be doing that part of it. You're going to be doing that on a web page and capturing that code somehow separately. But that's what that looks like. Okay? All right, so you can do two-factor auth pretty easily. So you can also do that in a desktop application, by the way. Right? You can ask people to scan with Authy from a FoxPro application, and then you can still do that validation as a second-level validation. So this is not only for web applications, which is not something you see very often, but it's possible to do. So, all right. All right, how do I get back to my, oh, okay, it's still here. Okay, spell checking words, I'm going to skip that one. Humanizing, I'm going to skip that one too. So I'm going to skip forward here a little bit. So the next thing I'm going to do is do a file watcher. Okay, so a file watcher is the ability to basically monitor a file system and be notified anytime there's a change. So now we're getting into something that's a little bit more esoteric, which is basically event handling. Okay, so the way this works is you set up the file watcher, and then you tell it which folder you want it to monitor and what file template you want it to look for. And then every time a file is changed, is added, deleted, or anything happens to a file, it will notify you. And it actually takes very little code to do this, but you need to implement an event handler that is responsible for handling the events for all those different things that can happen, right? You change a file, you rename a file, and whatnot. So let's take a look and see what that looks like. Okay, so it's telling me it's watching this folder with these files, and it's watching that folder recursively. So if I go back into my Visual Studio Code here, and I'm going to open, I don't know, it's one of these. So I'm going to open a PRG file. So, Visual Studio Code. Yeah, it's not Visual Studio, no. It's Visual Studio Code. Okay, so I'm in here, and I'm going to make a change, right? I'm just going to add a space in here. And there's the change. So basically, it's tracking, right? It's telling me that I'm making a change to a file, and every time I do this, it's now it's firing 2 events. And the reason for that is that it's tracking probably, there's actually multiple things changing on this. So there's probably, there's multiple attributes that are changing on the file. So that's why we're getting multiple events in this case. So you need to be potentially diligent about making sure that you're not getting multiple events. So, make sure there's a delay between the same file being loaded or whatnot. So here's something interesting. If I go in and do that in FoxPro, you'll see something a little different. So I'm going to make a change here. It deletes files and renames it. It's just pretty cool, right? To see that. So obviously, I'm not doing anything interesting in here, right? But if you need to know what happens when a file changes, it's pretty useful, actually. So let me just give you an example of how you might use this. So in Markdown Monster, I use this exact stuff. It happens to be a .NET application, but it demonstrates the point. if I open this up also in Visual Studio Code, so if I open, so I'm going to open the same document in Visual Studio Code. Okay, so I'm going to go in here and type a little bit. Save, right? You notice that it automatically picks up that change. Now, it also works the other way. So if I go in here, so as I type, it picks up those changes. And it does that using a file watcher, basically. It watches exactly that file template. And when that file is changed, it actually notifies you and immediately updates it because the document hasn't changed. But if I go in now and save this, now both of these are updated. So if I save this and update this, right, and now I save this, now this one didn't update because both of them had changes. But if I make another change here now and save, then it's going to tell me, hey, the document has changed, but which one do you want to use? Or do you want to compare? I can actually bring up Beyond Compare here to show me the changes, right? So this is the kind of thing you can do with a file watcher. Other things you can do is you can open another application, and as soon as you save, you can pick up the changes. So you can edit. And so, for example, if I have a text file that's a Markdown file, and I would like to edit that in Markdown Monster, for example, I can monitor the file, and as soon as I save in Markdown Monster, it can be picked up in my FoxPro application. Okay, so it's pretty powerful stuff. Cool. All right. And now destroyed that document. It will pick up changes in DBF files. It'd be hard to compare, though, right? Yes, but it would have to change, right? So if it's caching, it may not actually show up. All right. So what does that look like? Let me start my code again. So this is actually not that difficult to do. Again, we'll use www.NetBridge here. Oh, let me go to the top. So what we do is we create an instance of the system file watcher, and we pass a folder to it. Then we tell it to enable raise events and include subdirectories. And then we create an event handler. So the event handler is another FoxPro object that we create that matches all the events that the file watcher implements. So there's on create, on rename, on delete, all those events that are available there. We have to implement on this event handler. And the event handler is defined down here, and you can find those events down here. And that's basically where we're intercepting and where those messages are coming from, right? And then we can call www.NetBridge and tell it to subscribe to events. And we basically take the file watcher and we attach the event handler to it. And so that subscription is then created. And once we have the subscription, we're off to the races. And it's actually looking for events at that point. OK? Any questions on that? Very powerful stuff that you can do with this. Now, there's not too many things these days that are using events anymore in .NET, but the older stuff, especially the Windows-related stuff, there's still events involved. But this is a useful feature for a lot of things. So bookmark that one. Okay, off to the next one. Okay, I'm going to skip over that. I'm going to jump to the AI ones. Okay, so the next examples are also async examples. And these examples basically do something that is a long-running application. So making a call to OpenAI, basically, and then getting a result back. So you're waiting for a number of seconds for the result to come back. You can't sit there and basically block your application, right? So you have to do that asynchronously. And inside of .NET, there's lots of applications that or a lot of components that use async operations or task-based operations. So it's await, async await, if you've used .NET before. Okay, and so you can access that from www.NetBridge using the invoke task async method. Invoke method as, no, I don't know. What is it? We'll look at the code in a second. I can never keep that one straight. So let's look at the code.
10 minutes left.
Yeah, I'm aware. Thank you. Okay, so I'm first going to run it. I'm going to do the translation one first. So we're going to do OpenAI translation. And I'm just going to do it with the default. So there's the translation. Okay, so it goes from English to German. So it went up all the way to OpenAI and it was almost instant, right? Pretty cool, right? Let me open my help builder here for a second. If we go to session notes, let me find a few things here to translate. Oh. It's super fast, okay? And then I can also specify where I want to go to French. There's the French. Yeah. So we're actually going out online to do this. And we can also do this with a local AI. So if I go in here and change this to use Olama, which is a local engine. Oops. So I think that's running. And I have to change my configuration here to OpenAI translation. And if we go in here to the configuration, so here I specify a connection. I create an instance of a connection, and I specify my OpenAI key. And so instead of doing this here, I'm going to comment this. Yep. And I'm going to open this up and instead use the local Olama configuration. So I'm using an Olama configuration with the Llama 3, which is the Facebook model. Okay. So if I do this again, and I'm just going to do it with the default one. Oh, is it run? What do I want? Let me just run it. Did that go? Yep. Let me try it one more time. I don't know. Well, the local one, I think I didn't get it started right. Something's not right. It is running, but it's not recognizing the server. Okay, well, you get the idea. You can basically do this locally with the Olama engine, and it's just a lot slower. And in general, in my experience anyway, I find that the experience is a lot worse. So yes, question.
What's the main purpose of that? Like if it isn't connection and things, or
so the question is, why would you want to use a local SLM versus the LLM? Well, the LLM costs money, right? So you have to pay for it. And so if you're building an application that is going out to a lot of people, you don't want to have everybody have to have a subscription to OpenAI, right? So if you have a local SLM running, you can say install this, and then it just works and you can run it. But these things aren't small, so there is a benefit to running it locally, but it's not. I think in the current state, it's not really ready for it yet. I think it's coming, but we're not there yet. Okay, so let me just go through this code here so that we can get through this one. Let me just go back to the other one. Suffice it to say that that does work with the local AI. It's just a little bit slow. Okay, so we use this library called Westwind AI.dll. So I created this AI wrapper library, which is basically just an HTTP wrapper in .NET around the API interface. So it's very lightweight because it's only the HTTP wrapper, and I use it in Markdown Monster, and so it's a component. It's a NuGet package. And so this is what I use here. Now, we could have done this in FoxPro ourselves, but because it's all async, it's actually much better to do it in .NET and let it do its async thing. And so that way we don't have to worry about figuring out how we wait for this to complete and don't sit there waiting for a result to come back. Okay, so the way that this works is we create a connection, and then on the connection, in this case, I assign my key and I assign which model I want to use. So this is the default model, GPT-4o Mini. That's a very efficient and very powerful model. It's basically a trimmed down version of their big model. but it has most of the capabilities of the full GPT-4 model. And it's ridiculously cheap to use. I mean, I basically spend $20 every 3 months or something like that, and I use it a lot. Of course, it's for mostly internal use, but still, you know, it's ridiculously cheap to use at the moment. I don't think it's going to stay that way, but you know, there's that. Okay, so then the next thing we do is we create a completions object, and so that's the object that's actually going to run this operation. So generic chat client. And basically, I pass the connection to it. So that's the OpenAI connection at that point. And then I can optionally tell it, give it a role. So here I'm giving it the role of a translator. You are a translator, and you translate text from one language to the other. Return only the translated text. So you want to be as precise as possible. So OpenAI is really good about respecting this. The local AIs, not so much. They kind of ignore me all the time and put other stuff in there. The translation is usually good, but they put the other stuff in there, which is kind of weird. And then the actual prompt, right? So the prompt is going to be, I'm presetting this, translate from English to the language that I specify, and then I actually add a couple line feeds, and then translate the text that I'm providing. And so that's how that works. So that could be a large block of text or a small block of text, okay? All right, and then I call invoke task method async. There you go. Invoke task method async. Say that a few times fast. So then we pass a callback, right? Same as we did with the event handler, except this time around, the callback will be a lot simpler. We pass that completions object, so that's the object, and we want to call the complete method on the completions object. And then we pass the prompt as a parameter and the system prompt as a parameter. And I don't actually know what the last parameter is off the top of my head. Okay, so then the program immediately stops and finishes, right? So the program actually stops running because it's async. So then processing, and the callbacks are made into this callback handler here. And there's two methods that are made on these task methods. There's either success or failure. So we have an uncompleted or an on-error method. Okay, so this is for task operations. So any task either fails or succeeds. So one of the two things will fire, unless there's a crash. In which case, then, well, all bets are off, right? The machine crashes. Blue screens come flashing, and who knows. And inside of there, then, on the uncompleted, I just check for an error in case the result has some sort of error inside of it, and then we can go ahead and do that. Or otherwise, I show the translation that comes back. So in this case, the result is a string, which is the translated text, and that's what's coming back here. Okay. All right, so then I have two more examples here. I'm not going to get through them, but I want to do the image one because it's kind of fun. So I'm going to do OpenAI image, which is the image generation engine. So it works off a prompt. So this one has a fox that is dressed as a grungy punk rocker, rocking out aggressively on an electric guitar, using goldenrod colors on a black background in classic poster style format. And there it is.
In other words, the T-shirt you were wearing yesterday.
Pretty much.
Pretty close to it.
Yes. Yeah. So you can do this kind of thing relatively easily, right? So it's basically the same as Microsoft Image Generator, or if you use ChatGPT-4 and you do image generation. It's the same engine that's doing this, and you can plug this into your own application. And it's actually quite useful. I mean, I have this in Markdown Monster, for example, and you can, so here's the bridge demo that I used, that I generated here. Create an image. So if I run this again, it'll go out now and run this from within this application in my editor. And when the result comes back, I can directly paste it into my Markdown text, and it will generate the image and whatnot. So that is useful for a lot of scenarios when you need to generate the image content. For example, every time I write a blog post, I typically go out and try to generate some sort of image that goes with the blog post. Okay, and it's nice to have that integrated. Now I can go out to ChatGPT and do that. That's just as easy, but having it integrated right in the tool that you're using is pretty useful. Okay, I guess that means. Okay, so there's the image that was generated for that. And you can play around in Markdown Monster if you're interested. It's actually pretty cool. I use this for general image generation because it gives you all the options that you don't get in ChatGPT and other things. Yeah, I know we're done. Okay, so let me just go to my last slides here. I can find my, why is this not working? Okay, so as you've seen, there's a lot of cool things that we can do inside of .NET, and there's much more. In fact, there was a few more demos that I skipped over already. But you can play around with the stuff that's in there. There's more examples. There's an HTML to PDF generation demo. There's an AI text summary, and there's a whole bunch of other things that you can do to play around with. The white paper for this session is very long. It's 90 pages, but a lot of it is code. But I urge you to at least read the beginning of it, because the beginning of it has a lot of tips and tricks in it that I just can't cover in a session. And so there's detail in it on ILSpy, for example, and all the different decompilers. There's how to use LinkPad to test .NET code before you actually create it in FoxPro and whatnot. So the idea is to make it as easy as possible. And with www.NetBridge, we can access all of .NET's functionality. And it's relatively easy to do. But if the functionality that you're trying to access is more complicated, you will be better off building your own .NET components and use those .NET components to write a little bit of .NET code rather than trying to struggle through lots and lots of code and weird potential issues that you have to figure out. It's possible, but sometimes you write 3 lines of .NET code and it will be 15 lines of www.NetBridge code because you have to create all these other objects sometimes. Okay, so just keep that in mind. And then again, here's all the session notes and all the downloads that you can grab. Everything is on the GitHub site, so don't write down any of the, there isn't any links, but everything is on the GitHub site. So if you copy one link, that's the one that you want. Okay, so thank you very much.